All right, picking up where we left off, we're going to look at sources of error and types of error. So error in experimentation happens and it throws off our measurements. So the best way to deal with error is being able to recognize it and understanding how to limit it. So first type of error is systematic. Systematic occurs at each reading due to faulty equipment or procedure. For example, if the observer is less than perfect looking at the measurement in the same way every single time. If I'm doing a reading and I have to look at the reading straight on, well, that's going to give me an answer. If I look at it from a slight angle, it's going to appear that the reading is slightly off. For a demonstration of this, just go measure some water in a measuring cup or a beaker or anything. And then look at it from above. Look at it from below and look at it eye level. Remember, we want that eye level view of the meniscus. So that is called parallax error. That's a type of systematic error. Another type would be an instrument showing a reading of 0 when it should not. This is called a zero error. If you have a multimeter connected up and you're expecting 1.5 volts because you're testing out a battery and it shows 0, then that's a zero error and we can recognize it and fix it. An instrument that has been improperly calibrated, you put a 100-gram mass on a scale, and then you put a 200-gram mass on it, and you never zeroed in between. That may give you an improper reading if there's any kind of stuff left over on the digital balance. Random error happens when there's a reading at random. Very hard to reproduce, so it's going to show up in your graphs as an outlier. That's when an observer is being less than perfect. Could be from the readability of equipment. If you've ever used a calculator where it's pretty much dying, you can see some lines. Is it a 3? Is it an 8? Maybe it's a 5. So that could be a random error. External effects on the observed system. If you're taking a measurement and there's a wind blowing, so that adds some extra force behind something, so your force sensor's off. Those types of errors are random. If there's little random errors, then we are said to be precise. If there are little systematic errors, then we're said to be accurate. Ideally, we want to live in this neighborhood here: high accuracy, high precision. To reduce random error, take repeated readings. You cannot take too many readings unless you're on time constraints in a classroom experiment situation. The reason why that's going to reduce your random error is because it would have to happen at every single reading, and a random error, by definition, can't happen at every single reading. If it is happening at every single reading, then that would be a systematic error, and there might be something wrong with the procedure that you can account for. We'll stop.